14.7, apply double angle and half angle formulas. All right, so obviously you should have a list somewhere that you've written down for notes of all of these formulas. We are gonna kind of use the double angle ones in some of the problems that we're doing, but a lot of times, and more so like going forward when you get to pre-cal, those are gonna be more like coming into play with your verifying or simplifying and stuff like that of like ways to rewrite trig functions. So just be aware of that. Not that we aren't going to use them for anything else, but that's more where they come into play. And then half angle formulas get used in similar situations to where we use sum and difference formulas. But in a lot of cases, it's problems that like the sum and difference, there's not two values that like add up to equal what we need and stuff like that.
I think pre-cal is going to give me a headache.
Well, the good news is by the time we're done with this class, there really won't be a whole lot of new information in pre-cal. So most of it will be review.
I still don't understand this.
Wait, so it's like review for the whole year? Or just like...
Pretty much. I'm getting ready to get into brand new stuff with them that they've never seen before. There's like a couple sections here and there that's like new stuff, but most of it is almost identical to this year. And I'll tell you, with pre-cal, the first 2 chapters are the worst. You can survive those, you'll survive. And one of them's a review chapter, but I'm telling you, it's like everyone's least favorite. I don't know why, but it's like the hardest thing the whole year, in my opinion. And typically grades in pre-cal start down here, and then they do this.
All right.
So, just gonna preface that for you so that you're aware.
So if we do bad the first quarter, it's okay. Because it'll get better. It'll average out.
All right, example. Cosine of 165 degrees. So my first thing I'm always going to do is say, okay, is this a value that's on my unit circle? No. It is not. So that means that I need to, in this particular case, we're using, it says to find the exact value of the expression. Sometimes we'll be able to do things like the sum and difference formulas on these. But we're, context of the section, we're using half angles. So, I need to figure out what this is the half angle of. So, to do that, I'm going to double this value. And so, this is going to be the cosine of half of, what's double this number? 330. So, we're looking at the cosine of half of 330 degrees.
And that's only unit circle.
Yep. So then that's where my formulas are going to come into play. So probably before we have our next quiz, probably the day before, we might do it sooner than that depending, but we'll finish off the last of our cheat sheet for this stuff. So I have this cosine formula, cosine of the half angle.
Hello.
Hi.
Hey, are you able to pick up?
Greetings.
Yes. Hey. Yes.
You know I can't go to the office.
Okay.
Shut up.
I have, because Daniel and them have to leave by 3:40 to get to church. So I told the team they need to be ready at 3:30, like on the dot. But we're going to be at the mercy of Life Touch because of what happened during volleyball season. So I told them we're going to do team picture first. Like, I'm just going to tell Life Touch, you don't get to pick. We're doing team picture first, and then I'm going to have, like, Daniel, Hannah, Zach back to back. Go. Yeah. Right. Yeah. Well, in worst case, we'll do those. I'll be like, all right, we'll get those going first, and then I'll just be like, I'm sorry, but we have to transition. Like, I don't have a choice. So. Okay. Thanks, bye.
It is a reference.
Okay. All right, so this is my a value in my formula of the cosine of a over 2. Okay, so I go to my formula, and the formula for cosine, I don't know when you did this note, so I'm going to refresh, is plus or minus the square root of 1 minus the cosine of a over 2. Now, plus or minus is determined by the value of a over 2, which is this. So, is cosine positive or negative over here?
Negative.
The x values at 165 degrees would be what?
Oh, wait.
Negative. Okay, over here on the left-hand side, 165 is over here. The x values are negative, so that means that I'm going to be using the negative one in this situation.
I thought we were talking about like the number and stuff.
Oh, I know it. Yeah, I
I think
understand.
that's what we thought.
So this one's going to be negative, so I'm going to have negative square root. And if it's positive, what I like to do is I like to write the positive sign in front initially, and then obviously we don't really need to write a positive sign. It's assumed things that are positive. So then thereafter I don't write it, but obviously this one's negative, but you'll see what I'm talking about in a minute. So then we've got 1 minus, is that the right formula?
I think it's plus.
It is plus. I was like, something is not right here.
330. Cosine 330. Cookie! Cookie. What do you want?
I was giving you a high five.
Oh, well, you didn't move after I gave you a high
Sorry. Gosh.
five. No, you didn't move after you gave me a
Maybe I
high
want to
five.
give you both that.
We're almost done.
Wait, how many are left?
Right there.
5.
Yes. Yes, we are. Hopefully.
All right, so this is 1 plus the cosine of, why is that still green? Cosine of 330 over 2. So then what I do is I go to my unit circle, and I'm going to say, well, what's the cosine of 330 degrees?
Square root 3 over 2.
Yep, so I'm going to keep the negative sign. Then on top I've got 1 plus root 3 over 2, all over 2. So then what I like to do here is I like to on the top get a common denominator. So I would rewrite this as 2 over 2. And so I end up with on top 2 plus root 3 over 2, all over 2. Now, when I divide by 2, that's the same thing as multiplying by 1/2. And so I can change this to be the square root of 2 plus root 3 over 2 times 1/2. And so then on the bottom, this becomes a 4. So then I can take and split my square root top and bottom. And so I end up with negative on top, square root of 2 plus root 3. On the bottom, I would have the square root of 4, which is 2. And so then this would be my answer here. They look weird, but just like with the sum and difference formulas, when all of them were, for sine and cosine were some combo of root 6, root 2, and then 4, all of these are going to look something like this as well. Okay, well, sine and cosine tangent ones are a little different.
Of course.
It's always different.
Example, tangent of pi over 12. So with these, anytime I have a radian value, I would convert them to degrees first. Because it's going to make it easier for you to understand. So pi over 12 times 180 over pi. And that's going to end up being 15 degrees. So I'm looking at the tangent of 15 degrees. Now, that's not the half angle. Well, it is a half angle, but that's just me rewriting the first step. Okay? So 15 is half of what?
30.
So I'm looking at tangent of half of 30 degrees. Now, some people, when I get to this point, think, oh, well, I'm just going to go write whatever the tangent of 30 is. That's not what we do here. Okay? This is half of 30. So, tangent is the one where we have a couple of options for the formula. We have either 1 minus cosine of A over sine of A, or sine of A over 1 plus cosine of A. And I can use either one. I typically like to use the first one with sine of A on the bottom because then I don't have to, I can pretty much just keep change flip instead of having to multiply by a conjugate to get a root off the bottom. But it really doesn't matter. You can use either one. But I'm going to use the top one for right now. Again, just a preference thing for you. So we've got 1 minus the cosine of 30 over the sine of 30. So mathematically for these ones, tangent's actually easier, unlike the other ones that we've been doing. Tangent was harder. Tangent's easier on these ones. So 1 minus, what's the cosine of 30? 1/2. And what is the, no it's not. Yeah, I was about to be like,
Nice job.
it's not right.
Hey, I called myself.
And then sine of 30,
That's
that one is 1/2.
Good job, Cooper. I see. I read it down.
So again, I would get a common denominator on top here, so I would rewrite this as 2 over 2. So I end up with 2 minus root 3 over 2, all divided by 1/2. What happens when I divide by a fraction? Keep change flip, so I have 2 minus root 3 over 2 times 2. 2's cancel, and I end up with 2 minus root 3.
Oh, wow.
So mathematically, the tangent ones are easier. Okay, actually getting into a few
Difficult one.
book problems here. So all of these ones so far have been whole number values. That doesn't always happen. Number 4 is the tangent of 112.5 degrees. So on this last problem up here that we just did, the tangent of 15 degrees, I could have also, unless it told me explicitly, which this section is obviously double and half angle formulas, but if it was on a quiz or a test, or say your final exam, you could have done this one either by sum or difference formulas or using the half angle formulas, because I could have done the tangent of 45 minus 30, and that would have also been the tangent of 15. So that's another way you can check the problem. If you get stuck, you can check it with that method. With one like this one, I can't use the sum and difference formula. My only option is half angles. Why?
Because it's 0.5.
Yep, because it's a 0.5. There's nothing that I can add together off my unit circle that's going to give me 112.5 or subtract.
Is it always going to be like 0.5 or is it going to be like 0.3 or like 0.5?
It would have to be a 0.5 because when you double it, it has to be something that gives you a whole number value.
Sounds great.
Otherwise, you would pretty much just have to plug it in and check it. Now, another thing that you can do to check these problems is you can type in radian mode the tangent of pi over 12, or in degree mode the tangent of 15 degrees, and you'll get a value. You can check that by typing in 2 minus root 3 to your calculator, and you'll get the same answer, like decimal wise.
That close, right?
Huh?
Did you clean part of that room?
Part of that room?
No, the boxes are just in the middle of the floor.
Wait, what?
This is so
Wait, what?
crazy.
The
It just
jerseys.
looks cleaner over there and I don't know why.
Because the jerseys are over here instead of over there.
How does tangent relate to boxes?
I was just looking over there and there it is.
All right, so tangent of 112.5, that is the half angle of what?
225.
225. So now I can use either of the formulas. Do you want to use, I'm just going to do it this way. Do you want to use the first one or the second one?
First one.
Okay, so we'll have
Mistake this time.
1 minus the cosine of 225 over the sine of 225. So this is 1 minus, what's the cosine of 225? Negative root 2 over 2, so I'm going to change this to a plus sign here because this was 1 minus a negative, so plus. And then sine of 225, negative root 2 over 2. So then again, I need a common denominator on top, so this is 2 over 2. And as soon as you like start working this problem, like if you see that that's that, you can just rewrite this 1 as 2 over 2. Like you don't even have to write a 1 at all. You could just literally write it so it looks like that instead. That's just up to you. But so then on top I have 2 plus root 2 over 2, and then all divided by negative root 2 over 2. Dividing by a fraction, so I'm going to multiply by its reciprocal. So I'm going to keep change flip. We've got 2 plus root 2 over 2 times 2 over negative root 2. And the negative just goes wherever. It doesn't matter. But so those 2's will cancel.
So it's 2.
So I have 2 plus root 2 over negative root 2.
Can't have the thing on the bottom.
So what do I have to do to fix it? So I just need to do the root 2. The negative, technically speaking, let me do it this way so it's not confusing. The negative is just going to be out front, basically. So I'm going to multiply top and bottom by root 2 because I've got to rationalize it because we can't have them on the bottom. So then on top, I'm going to keep my negative sign out front. I'm going to have 2 root 2. Yep. Nope, not plus 4. Root 2 times root 2 is the square root of 4, which is 2. And then all over 2 on the bottom. I can take a 2 out of everything. So I'm going to have 2 times root 2 plus 1 over 2. 2's cancel. And I end up with negative parentheses root 2 plus 1. Or you can rewrite this as negative root 2 minus 1 also would be acceptable.
Goodness gracious.
The root 2 over 2 ones honestly are probably the worst ones just because like you have square roots, and if one of the values like, well, with sine and cosine, obviously if one of them's root 2 over 2, then the other one's also root 2 over 2, which means that mathematically it's going to make it a little bit more difficult. But
It's already pretty difficult.
All I hear is 2, 2, 2, 2, 2.
2 root 2, 2 times 2 times root 2 divided by 2.
Thirsty?
Yeah.
First try.
all right, number 6. Cosine of negative 75 degrees.
You know, this is so fun.
But yeah, so
We have to do the double thing, right?
The what? Oh, yeah. I know what you're trying to say, yes. All right, now, what do you notice about this problem compared to all the ones we've done so far?
It's a negative.
Yeah.
It's negative. So, the first thing that we're going to do is we're going to figure out what the half angle of it is, which is still going to be a negative angle, right?
150.
Yep, so this is going to be the cosine of half of negative 150. But I can technically count backwards to negative 150, but what would be easier?
I don't know.
Find the what?
Starts
Starts with a C.
Uh,
C-O-T.
Common?
CT?
Cotangent?
C-O-T-E.
coterminal angle.
Coterminal angle. How do I do that?
You look at your answer
You look at the circle and you find
and you
the
look at the.
opposite.
Yeah,
of
that's
the
what I
other.
was getting to.
How about add 360?
Or that, yeah, that'll work. Cooper?
I'm fine. Y'all are saying
So I'm going to add 360 to this. So I'm going to treat this as the cosine of half of
Oh.
It's 210.
Yeah, that.
210.
Y'all.
Yeah, it's a Tuesday.
Hey, you don't have glasses on.
Wow, hooray. Figured it out. You looked at me.
Okay, so
Oh, it's because Ella likes them.
It's because I got contacts and another paid for it.
So-
Moving on.
is cosine positive or negative at negative 75 degrees? We have to go back to the original thing or you're going to end up getting it wrong. Positive, because that would be on the right. If it's negative, it would be down here at the bottom. Okay, if this was, it'd be down here, so it's going to be positive. So what I like to do when I'm writing this, I like to write a giant plus sign so I know I've checked that. I won't write it again after this, but at least in my first step, I know, okay, I've done that part. So then I have the square root of 1 plus the cosine of 210 over 2. So then I have in the square root 1 plus, what's the cosine of 210? Negative root 3 over 2, so I'm going to erase my plus sign and write minus root 3 over 2. If you want to get rid of that 1 and write it as 2 over 2, you can do it. Go ahead and do that. So that means that in my radical on top, I have 2 minus root 3 over 2 all over 2. So then I can multiply by half. So this is 2 minus root 3 over 2 times 1/2 all inside the radical. And once you get used to doing this, you can just go straight to skipping this step and writing this as being over 4 if you want to. So then this is the square root of 2 minus root 3 over 4. We can split our square root top and bottom. And so then on top, I have the square root of 2 minus root 3. And on the bottom, not in the square root, I would have a 2.
Wait, how did it change? Oh, square root of 2. What is 2?
It's because the pi sign is gone. That's why that wall was empty.
Oh.
Oh, it does.
Is that why you thought it was clean? It just looked emptier, and I was thinking maybe it was cleaner, but it's because the pi sign is gone.
That's great, Aggie.
Thank you. Okay.
8. The sine of 5 pi over 12. What's the first thing I should do?
Convert.
To a degree.
Make it in degrees. So 5 pi over 12 times 180 over pi.
Oh my goodness, it's so
Tell it who's gone.
75.
I was. Shut up.
All right, so again, this is just the rewriting step. This is the sine of 75 degrees. So I need the half angle of what?
150.
Yep, so this is half of 150.
Feel like we already did this.
We did, but we did with cosine.
So again, this is one with the sine of 75. If it doesn't explicitly tell you what to do, you could use sum and difference formulas and do like 30 plus 45 on that. But obviously we're doing half angles in this section, so it's what we're doing. But and so then we have the formula for this one. We haven't written signs yet, I don't think. Plus or minus the square root of 1 minus cosine of A over 2. I picked the right one this time. Yes. Okay, so is 75 the sine value positive or negative?
Because it's in quadrant one.
Positive because it's in quadrant 1, so I'm going to write my giant plus sign one time.
Big
Aiden.
Again, if you don't write it, it's not wrong. It would only be wrong if it was supposed to be negative and you didn't write it. But I just like to write it so I know I've at least thought about it. 1 minus the cosine of 150 over 2. What's the cosine of 150?
Negative.
So this is going to be, instead of it 1 minus a negative, I'm going to write it as 1 plus root 3 over 2. All over 2. So I'm going to rewrite 1 as 2 over 2. Now, can we jump straight to saying that this is 2 plus root 3 over 4? Are we ready for that?
Yes.
Yes.
Okay. I'm just skipping. All I'm doing is skipping this step of rewriting it this way.
I was wondering if that was a trick question.
I'm just skipping rewriting it this way to save a line on my paper.
Alright.
Not that it really matters for my iPad, but, you know. So this is going to be the square root of 2 plus root 3 all over 4. And then I can write this as the square root of 2 plus root 3, and then not under the radical, a 2.
Yay! Can't wait to scrub my face.
All right, find the exact values of the sine of a over 2, cosine of a over 2, and tangent of a over 2.
Whoa.
So these ones, they give us, like with number 12, the cosine of a is 4 over 5. And then we have 0 is less than a is less than pi over 2. So what does that tell us about a? Where is a? Okay, it's in quadrant 1, so that's going to be the first thing is I'm going to draw this, okay, of what this looks like. So,
redraw the triangle,
yep. So cosine is adjacent over hypotenuse, so that means that this is 4, this is 5. I think we should know this one by now. What is this side then? This is a Pythagorean triple.
Great job.
Who said that?
Claire.
Not me.
Good job.
It was definitely not me.
This is a 3, 4, 5 triangle. If you don't know that, then you need to do the Pythagorean theorem to find it, but this is a Pythagorean triple. 3, 4, 5. Just remember that.
It's like counting out.
3 squared plus 4 squared equals 5 squared, so it's called a Pythagorean triple because it's like all whole numbers.
Where's Cooper? No glasses.
Okay. So what I need to do is I need to write down what the sine of a is. I already know what the cosine of a is, which is 4 over 5. And then the tangent of a. I don't necessarily need that one, but I write it anyways. So what's the sine of a?
3 over 5.
3 over 5. What's the tangent of a?
That's it over adjacent.
3 over 4.
Not 4 over 3.
All right, so what they want me to do is they want me to find the sine of a over 2. So all that means is that I'm going to take the formula for this, which is the square root of 1 minus the cosine of a over 2, and I'm going to plug in this cosine of a is 4 over 5, so I'm plugging in this value to this problem. So notice, these ones, the final answers are going to look different than these previous ones because these are not unit circle problems. So this is going to be the square root of 1 minus 4 over 5 all over 2. So instead of this 1 being 2 over 2 this time, it's going to be
5 over 5.
5 over 5. So on top, I have 1 over 5 all divided by 2.
I'm really lost.
Because
Before the 5 was there, the 5 over 5 was there, what did it look like?
1.
It looks like
Oh,
that.
Okay. Got it.
And then we just rewrote this so I didn't have to use another line to change the thing. So 5 over 5 minus 4 over 5 is 1 over 5, and then all over 2. We still are technically dividing by 2 is multiplying by 1/2, so then that's going to be the square root of 1 over 10. which then can be written as the square root of 1 over the square root of 10. What's the square root of 1? So we have 1 over the square root of 10. Can't leave it like that, so what does this become?
Square root of 10 over 10.
Yep, so we'd multiply by root 10 over root 10 to rationalize it, and so we'd end up with root 10 over 10 as my answer for the sine of a over 2.
Goodness gracious.
My brain.
The cosine of a over 2. And notice these ones are positive because we're in quadrant 1. Okay. Cosine of a over 2 is the square root of 1 plus the cosine of a all over 2. So this is the square root of 1 plus cosine of a is 4 over 5. So 1 plus 4 over 5 all over 2. 1 is 5 over 5. So this becomes the square root of 9 over 5 all over 2. Multiply it by 1/2, and so we get the square root of 9 over 10. Come down here. So,
3 root 10.
yep, so square root of 9 over square root of 10, which is going to become 3 over the square root of 10. Rationalized then becomes 3 root 10 over 10.
My problem is like I understand it when I'm doing the notes, and then I like go back when I'm on the homework and like try to understand what I was doing, and I was like, I'm just like, no, it just doesn't make sense.
Tangent time. Oh, maybe not, yeah.
I try to write as many steps for you as I can to try to help with that. Sometimes it's hard for me to write every step. I'm like, I'm struggling. All right, tangent of a over 2. Which formula do you want to use?
Yeah.
Is that the 1 minus cosine of a1?
Yeah.
So 1 minus cosine of a over sine of a. So we've got 1 minus cosine of a is 4 over 5. Sine of a was 3 over 5. So on top, I've got 5 over 5 minus 4 over 5. So that's 1 over 5 all over 3 over 5. Keep, change, flip. So I have 1 over 5 times 5 over 3. 5's cancel, and I'm left with 1/3.
That wasn't that bad.
That's why I said tangent is going to probably be the easiest ones because there's typically not square roots unless you end up with like the unit circle root 2 over 2 ones that we had before.
Oh my gosh.
I don't know what just happened.
He's hyperventilating.
Okay, we're going to pause there.
Yes.
Problems up to this point. 3, 5, 7, and
3, 5, 7, and then 23 through 50.
15.
That's it.
Yep. Now, we're not done with this section. We've done half angles. Tomorrow we'll do double angles, but I would suggest you work on these problems now while this stuff is fresh in your mind because we still have about 12 minutes left.
I can't do that.
No, not shut
Now, you're not turning these in yet. You'll hold these, so you might want to like start a paper that you can then add the double angle problems to. But I would suggest you start working so that it's not, awful. We'll probably do 6.1 on Friday just for your.
What?
So no.
Oh.
I might not be here Friday.
Yeah, I need to post them. Are y'all going to Tennessee also?
Huh?
Are y'all going to Tennessee also?
No.
Wearing them by.
I'm being Virginia Beach because my cousin has a
Don't
national
know
track
why
meet.
she was doing that.
Ah, gotcha. I just know